Yeah, go ahead.
So devices are like there two devices are used to connect internet between. It's used to connect and yeah,
Yeah,
to
so
get the net.
basically,
Yeah,
let's say you're sending a WhatsApp message, right?
yeah. So I need.
That message has to go to other device.
Yeah, correct. So I need two
Right.
device.
So
One device has to be used for sending it, and one device has to be used for receiving it.
correct. Then the next, what is network interface card used for?
Network interface card. Mm, Network interface card. No, I don't remember
Okay.
much, but yeah.
You remember the picture which I shared last time of network interface card? Yeah,
Yeah, yeah. This one.
this is a network interface card. So basically, the ports that you see, these are the hardware ports. Do you see that hardware ports?
The small ports.
So
Yeah.
you notice these ports are designed in a particular way, like to fit the Ethernet cable. Not any wire will go in this, no?
Hmm.
So they're designed for to talk on networks, you know. So any device that has to speak on the network, computer network, they have to go through this door, network interface card. If you don't have network interface card, you cannot speak to anyone on the internet. You cannot send even, let's say, WhatsApp message. Everywhere all the devices have some kind of a NIC placed in the hardware where see, ultimately it is all electricity, right?
Hmm.
How does electricity convert into digital messages? That is there is a lot of conversions, and there is a then even if the data is sent, how do you know whether character A was sent, B was sent? So there is a lot of processing that is done just based on your signal, whether it is on or off, whether it is 0 or 1, because in digital world everything is 0 and 1, like either it is on or either it is off. So based on these combinations we determine what the other person is trying to say. But digital signal 0 and 1 is digital, but electricity is analog, right?
Hmm.
Like it is continuous, it is electrons. So how does that convert into a digital signal? Then how does a digital signal convert into your actual message? That is, so network interface card is your interface, it's like a door or interface to what, to the network. That the very word, it says an interface to the network, that way. So that is what is network interface card. So do you understand? So if you want to get on the network, you cannot get on the network without network interface card. Every device there will be one network interface card, one device, one card.
Hmm.
Okay. So two devices are there, then two interface cards are talking to each other. So it is not your device which is talking to each other ultimately. It is this piece of hardware which is making that communication possible. Okay.
Hmm.
So if you have a TV, then you want your TV to computer. The earlier TVs, sorry, the earlier TVs were just give me 1 minute. Huh?
Yeah, sure.
Okay, I'm back. So if your TV has to become like a smart TV, right? Earlier TV was not smart. So now if the TV has to become smart, which means it has to understand your digital signals, it has to be able, it has to become like a computer, then it will require a network interface card. Is that okay?
Yes, sir.
Okay. Then can you explain the rest of the stuff? What is cables, hubs, switches?
So cables are like which we use to connect that network. Hubs are like there are many ports which are there, but currently we don't use hubs. Um,
Hmm.
so it has like multiple ports. You had shown that, like
Correct.
you had drawn it, right? Uh, so
Yeah.
that is used to connect the different computers.
Yeah. So this was the earliest connecting device, even before switches had was manufactured. So the thing is, the hubs they operate in a way where they uh, they work in half duplex in the sense when if two devices are talking to each other, it can only one person can say one device can send the signal or send the data at a time. Both of them cannot talk to each other.
Hmm.
Example we see even in walkie-talkie, right? In
Hmm.
walkie-talkie, only one person is able to talk at a time. But in a phone, when you use your normal phone, both the person can talk at the same time without losing the data, right? You can hear both the sides at the same time simultaneously. In walkie-talkie, you cannot hear both the persons at the same time. Only one side will be on at a time, and that is what the hubs were earlier days connecting kind of device which would connect the two devices using hubs. So it was operating in half duplex. Half duplex means you can either send or receive, but you cannot do both.
Hmm. And I think in switches we can send and receive at
Both
the
at
same
the same
time.
time. Yeah. So right now everybody is using switches and
Switches.
because it is getting cheaper. Hubs are no longer make sense.
And routers are like where this IP address.
Yeah, basically routers are your interface to the networks. Let's say you
Yeah.
want to switch from one network inside your network to another network.
Hmm.
Then that bridge is covered by the router. If you want
Router.
to, yeah, the device now the other device, what happens? Not necessary. All the devices are connected to your switches. No, you may have 10
Hmm.
devices connected to your switch. That switch may be connected to a router. So till then, you are connecting, you're talking to devices inside your network. That switch will take care of it. But the moment you want to talk to another device, residing in some other network, connected to some other switch, you require a bridge, and that bridge is router. So
Hmm.
usually, when we want to connect to an internet, we have to cross that bridge from your network to the internet. So who is providing the internet? The ISP, like ASCII.
Hmm.
So they have their own routers. So and they have their own IP address. So the router to router, basically anytime you want to go on to the other network, the router has to find a way to reach that IP address. Ultimately, the entire work of router is you give the IP address. If it is inside your network, it will simply circulate you back into the right device inside your network. When router does not know now this IP address, it is not in your network. Then what does it do? Then it moves into this another process of discovering where this IP address is, and that is where if it is if you have given a domain name which is like your phone directory,
Hmm.
you give a name, you find a phone number. So if you have used a domain name, then it will try to ping the DNS server. So DNS server already you should know, no, because routers have to know which DNS server to contact.
Hmm.
That DNS server will have an IP address for sure. So for example, if you look at you know top level domain servers, TLD. So Google has free DNS servers where you can look into the database, or it has all the IP addresses, and it can resolve that name. So let's say Google top TLD free server. It's actually 8.8.8.8. So it says it's a public DNS, means that database is open for all public.
Hmm.
So this is like a phone directory. So you have to know the IP address of the DNS in order to make a DNS query. Correct? If so once you get send, so you have to send a request that this is the domain name. Please tell me the IP address. Once the IP address is known, the IP address, the router tries to know in which network this belongs to. Every network address or IP address will be one section of the IP address will tell you which network it belongs to, and another part of the IP address will tell you which device it is trying to reach to. So in the single network there can be 10 devices, but which device you are talking to. So for that reason, the complete IP address gives you both the network address as well as the host address.
Hmm.
Are you getting it?
Yes, sir.
So once the DNS responds back with a DNS query, so DNS query is a query are querying for a particular for the IP address of a particular domain name, or for whatever name it is. It is like looking in the phone directory. That is what the role of a DNS is. Once you know the IP address, the router's next duty is to find travel. Basically, it is like railway connecting lines. So let's say you want to know, you want to go to Sikkim. So Sikkim, you will once you have to know to Sikkim. Then from Mumbai, you will try to find the routing stations. Okay, now I jump from this station to that station. I go from Mumbai all the way to Kolkata. Maybe from Kolkata, I take another route by bus or by rickshaw, and then another routing station I'll drop in there. So basically, you need to find a path, through the network. All the systems are ultimately connected, but which there can be many routers on the way, right? But before you reach from Mumbai to Sikkim, there may be many stops. So every time, so the router has to decide. Not, yeah, it has to know the end destination, yes, but it doesn't has to determine totally the end destination. It has to determine the next destination, the next router, because one router may be able to reach many other routers. So which router should I jump to? That is the question, right?
Hmm.
So are you getting the role of routers? They help you route through the network. It has got nothing to do with device to device communication. It is all about your railway lines. Okay, the train is like your data, but the stations are like your routers. Okay, so one station the has to decide where this train should stop next. Which is the next station, which is the next router.
Yes, sir.
So you understood now what DNS is, right?
Yeah.
And what is internet?
So internet is like the what we are using, right, to connect and
It is a
communicate.
network of networks.
Yeah.
When you're talking about all these routers and
Hmm.
switches, it is nothing but a network, right?
Hmm.
It is a network of networks. It is a network of all routers. Is internet, you can say,
Hmm.
right? Internet has got nothing to do with websites. Internet is only about networking. Now, how you use that networking, that is your physical, your infrastructure. All the railway stations are there, all the trains are there. Now, how are you going to send, let's say you want to send a parcel or you want to send, industry parts. So whether you're going to use a cargo train or whether you're going to use a passenger train, all those rules will is secondary. You just have to, one is like you just your internet is like your network of networks means it is linked to all the interconnected devices. What devices are we talking about? Routers, switches, then the switches are connected to cables are connected to ICs, and ICs connected to device. So that is what internet is. What is web then? What is the difference between internet and web?
So, web is a website, right?
Yeah, so web, when you talk about web, you're talking about websites. And when we talk about website, what are we talking about technically?
Mm,
In webs, for any website, what all components are there? So first is the website where it is hosted, no? Where your
yeah,
website is
the
running.
hosted. Yeah,
So
correct.
you definitely have a web server.
Yeah,
Second thing, what is there in the website?
web server.
Your browser, right?
Which
Your
browser am I trying to
browser is going to
access it?
access the web server. What is the third thing?
Maybe the link.
So HTTP protocol is being used. It
Yeah.
is a language tool. It is a web language. HTTP.
Hmm.
Okay. So in HTTP there are four types of four to eight methods, right? Get, post, update,
Hmm.
delete. So that way. And what else we have in web application? HTML pages, right? You construct your pages, then that is
Yeah.
converted to HTTP request. Everything will go in HTTP request and response format, but the output, the ultimate output is HTML, right?
Hmm.
Ultimate thing that you see on the browser is HTML. And what else? What other types of files are supported?
CSS, JavaScript.
CSS, JS files, and now they also have this server side scripting like ASP,
Yeah, ASP.
JSP, Node.js. Everything
Hmm.
is where code is running on the server side. So this is what the web is. Now, now that you've understood the difference between web and internet, like does this got to do anything with internet exactly?
No, not directly.
Not directly, right? But indirectly, web is using internet, which is it is using the network of networks. So
Yeah, to
in
connect
order
it.
for any browser to connect to a web server, browser will give a domain name. So what is
Hmm.
that in between thing in between over here, which it has to pass through before reaching the web server? Whom does where does the domain gets converted to IP address? You type
Domain,
www.google.com, no? After that,
Yeah.
how does it convert to IP address? Just now I explained, no?
domain name server.
Exactly.
Yeah,
So it has to
DNS.
go through the DNS. So DNS is part of the web also. Okay.
Hmm.
So that is what this is entire thing web. And on what platform, what infrastructure platform does web operate? It operates on the internet, which is your
Hmm.
network of networks. And how does internet work? With the help of routers, switches, cables, network interface devices, and everything.
Hmm.
So is it very clear now?
Yes, sir.
Okay, so if any question comes on DNS in web and internet and switch, at least this much you should know. Okay, how
Hmm.
is our entire world working?
Yes, sir.
So now we will. So Anuj, how is the means? Are you learning anything new from these sessions, or is it too simple? Do you have
No,
any
sir.
feedback on this?
It is good, sir.
Okay. So what is a new thing that you learned from the last lecture and this?
Sir, actually, I don't know much about networking, so I'm
Oh,
getting it
okay.
now.
So everything is new for you. You're saying?
No, sir, actually, the terms I have known already, but
Okay.
now I'm getting more about it.
Okay, now is it at least very clearer? Is it like very clear in your mind how
Yeah,
the network is placed?
yes, sir.
Very good. So once we have understood this, the next thing we'll try to understand the OSI model. So OSI model. So as I told you, one is about your like in your railway station you have stations. You know, it is like a routing stations. But there's a other thing, that the train itself, right? The train carries the cargo. The cargo is like your data. So that data, how do you make sure you send it across? Now, so when you send the data, what are you trying to say? I am sending a message, but the question is which application is sending the message, and to which application it is sending. It is not only device to device, no, it is also application to application. Which application is sending to which application? The WhatsApp message cannot go to as a mail to Gmail, no. So though that is a different application. So the thing is, the data has to be wrapped in such a way so that it reaches is not only the intended device but also the intended application. And that is where this and how does this data ultimately at the application level, it is like looks like a software, but somewhere down the line it has to get converted into your electrical signals. Your cables are nothing but your electrical signals, right? So so how does that has to be converted back, so there is a physical layer, is a lower most data transmission layer which deals with your electric signals, but this electric signals has to go all the way up to the application just on one device. Do you understand that? In just one device you type in something in WhatsApp application, that data then has to be, you need to add more information on it so that you can channel it ultimately through the cable, and that entire cargo then goes like in one parcel to the other end. In the other end has to unwrap it. They have to once they unwrap it, they try to see, what is there in the physical layer, what is there in the data link layer. So every piece of this layer is adding a piece of extra information, so that on the other side when the device wants to actually get the data, they are very clear which device this data is for, which application is this data for. um like, do you have any like idea about OSI? What do you understand about OSI? Any idea? Anuj, when you say hello, can you hear me?
Yes, sir. What?
Yes, sir.
Yeah. So OSI, it stands for even Open Systems Interaction. Okay. Now, just tell me, what did you understand just now when I told you about Open Systems Interaction? What did you understand when I explained you OSI?
So the way you were showing that it takes for a single system to connect from the electrical device to the way it is connecting between the layers.
Yeah. So basically, you have a phone over here. Let's say this is your whatever phone, let's say you have an iPhone over here. So now this device has to talk to another device, which is you may probably go through the Wi-Fi or a cable. That is like a chain of your it is at part of the journey will be through the Wi-Fi, part of the journey will be through the cable. So that everything, but still it is like a railway station. So now if this device has to talk to this device, it is not only exactly device to device, right? What it is actually, it is you are running like 4 applications on this. So this application is WhatsApp over here. How does this WhatsApp knows that it has to send a message to this WhatsApp? Why there is no confusion? between this WhatsApp and some other tool, like let's say Instagram. How are they? It is not only communication between device to device, it is also a communication between application to application, right?
Yes, sir.
So when you type something over here, how are you? How are you is like your English language, right? Now ultimately, this person just has to know, or this the other person has to just know whether what is the message. It doesn't has to know what device are used in between. So
So,
sorry.
sorry to interrupt you. Last week you said that these all are like now also you said that it's all getting converted, right? Like it doesn't understand the English language and then it gets converted.
Right. Ultimately, the data is traveling on some wires and Wi-Fi signal in form of this way, zeros
Binary
and ones. So
numbers.
all this has to get converted. These are bit, these are all bits. This has to get converted into your actual message. So there is a lot of not only data conversion process, but also data transmission process. Because when you want to you switch on a light, the light has to know na, whether the light is switched on. So there is an electrical signal going through it. So now the electrical signal, when you're sending the data, this electrical signal will be continuous. Sometimes it will be there, sometimes it will not be there. So so at this level, a zero would mean switch off, and one would mean switch on. So if anyone wants to send data between device to device in the form of bits, what they can do, they can use it, they can do it like a torchlight, on, off, on, right? This is the only way you can tell the opposite party whether I'm a zero or whether it is a one. But zero or one doesn't mean anything to you as a user. This this data is managed by the physical layer, so what of the system. So what is the physical layer of the system doing? It has got nothing to do with which application you're dealing with. It is all about device to device signals, that is going through. Either you're sending a Wi-Fi signal, or you're sending a remote from your remote to your TV, you're sending a infrared signal. Either you're sending you have connected the two computers using a wire, direct wire. So it is a direct cable to cable, one cable endpoint to another cable endpoint connection. So one end is sending the signal and the other end is determining whether it is a switch off or a switch on. So do you understand the role of a physical layer in the OSI?
Yes, sir.
Okay. On the very extreme, here this party doesn't have to know whether it is switch off or switch on. By the time it comes here, you have to tell me that the message is how are you. So this is a application to application communication. So how does this happen? So what can happen is this layer will take your first 8 bits and say this E means A, or this means H, how are you, right? And then it will combine another 8 bits and it will determine the next character, right? So the next character can be O, right? And the next character can be interpreted as W, and so and forth. So so this format, when you're using I think ASCII is 7-bit, and so ASCII format is I think a 7-bit format, which already has been the standard has been set. A means 65, or so you can convert your, this is your decimal bit. So so for example, this means 1, you know if you want to represent bits into decimal 0010, what is this, now tell me? Any idea? 0010 is what number?
Four.
It is 2 raised to 1, no? It is 2.
Sorry, 024. Right, sir.
Yeah. 0011. How do you change? Basically, this is 2 power 0, which is
One,
2 power 1,
two.
right? Which is 2.
Right, sir.
Then you add it, and then once you add it, that is whatever number you get, that is your decimal. So
Right,
this
sir.
is
Okay.
this value is 3 actually, right? Then
Hmm.
what is 0100? So this is 2 power 2.
Four.
2 power 2 is
4.
4. So rest of them are 0, means you have got nothing to add. But let's say you had a 1 also over here. This is 2 power 1, which is 2. This is 2 power 0, which is 1. So the total, when you add it, it is 4 plus 2 plus 1, which is 7. So this number is 7.
Hmm.
7 means A, 3 means F, 2 means E. So do you understand this decimals ultimately have to be, every set of set of bits is converted into one character. So there is a mapping. Somebody has to do that conversion. So this conversion is done by which layer? Who is responsible to do that conversion? That conversion is done before you give to the application. The presentation layer will be responsible for it. So presentation layer is doing all these conversions for you. You know, let's say somebody is sending the data in ASCII format and you want to convert it to Unicode. That conversion will be taken care by the presentation layer. Ultimately, this. So that is what the OSI layers are all about. Each layer is responsible for a certain task before it reaches the application. So what is a Unicode? Anyone tell me?
So, every character has their code basically.
Yeah, so this I said 65 means A, no, capital A.
Yeah, sir.
66 means capital B. 67 means capital C. Now the thing is, if you are in ASCII format, it can support only the characters A, the normal English characters A to Z, A to Z, 0 to 9, and some special characters like minus, plus, greater than sign. All these are special characters. Now the ASCII format, is let me just open. So the earlier days when they wanted, earlier days when the computer started, ASCII was the most prominent, you can say data encoder. So ASCII is how many bits? They're saying it is 8 bits, right? So the maximum number of 8 bits means, it is like it picks up 1, 2, 8 bit means 1, 2, 3, 4, 5, 6, 7, 8. This is the maximum value that you can get in a ASCII format. Is this understood? Is this
Yes,
Yes,
sir.
sir.
like, do you agree this is the maximum value you can get in bits in with 8 bits?
Yes, sir.
So the question is, what is this value equal to? It is equal to 2 power 8, right? Something like that. So this will come out to be, I think, 256 characters. So you can, but do we have only 256 characters in the world? There is Chinese character, there is Sanskrit characters, there are so many languages. And if you want to write in those languages, then how do you represent those characters? And that is where Unicode is coming into picture. Unicode, you can have a bigger length like a 32-bit Unicode, a 16-bit Unicode, a 8-bit Unicode. The more the number of bits you use, the greater is the character set. And but the greater the character set also means each character will take more bits. Okay, is this understood? Greater the character set means, which means if it is 32-bit, then each character will also take 32 bits, which means it is bigger. Sometimes if you just want to send ABCD, like you all those characters can go easily in ASCII format. You don't have to, if you have to send 8 instead of sending 8 bits, if you have to send 32 bits for every character, then amount of data that is sent is more, and hence your definitely then you're using lot more data. It may not be necessary. Unicode is mostly necessary when there are multiple languages being used and multiple character sets being used, because different languages have different characters. But at the device level, will the physical layer, doesn't matter whether it is Unicode or whether it is ASCII, it doesn't matter. What matters is at the presentation layer. By the time these bits are reaching to the presentation layer, each layer is giving the handing over is like a baton in your relays, right? Your relay sports. One is passing on the baton to another person. So by the time the data reaches here, the presentation layer has to make sure any conversion that is required into whatever format, and whatever format the application wants. One application may want it in ASCII format, the other application may want it in Unicode format, right? So it depends on which application we're talking to. One application may be a Chinese language application. One application may be a simple English language, so ASCII will work. So all this work is done by the presentation layer. Is this understood? What is the application layer, or what is the presentation layer, what is the physical layer? Little bit at least you understood.
Yes, sir.
Yes, sir.
So that way there are 7 layers. The physical layer is the layer which is closest to the hardware. The application layer is the layer which is closest to the software. So when somebody from one application has to send the data to another application, the application layer gives it to the presentation layer. Now what data is important? The application has to convey some information to the presentation layer. What is that one piece of information which would be very important to convey before sending the data across? Presentation layer input will be what? It has to know the data encoding format, right?
Yeah, which format it has got
Yeah, so
converted
this
into.
fellow must be sending in ASCII format, but presentation layer has to be told, please send it in Unicode format. That job is your job, presentation layer. So application layer has to make sure it's indicating. So presentation layer header will definitely contain those flags, whether this conversion is required or not required. If required, then which format you want it. All that has to be there, and then the presentation layer will pack the data. So application layer data will have application header and its own data and its own footer. But when you send the presentation layer also will have its own header. In the header, what will be there basically, whether it is an ASCII format or whether it is, those kind of information is very important. So there will be a data and a presentation footer, but this data has come from where? From top. So whatever this data is there, becomes the data part for the next layer. So are you getting the how this information is building up? Initially it must have been only let's say 20 bits over here, this piece of information. By the time it reaches here, it may be 30 bits. So that 10 bits was added by the presentation layer in terms of header, footer, or whatever extra information it wanted to add. So this data, when it was sent, it may be in Unicode format, and this data which was sent, it may be in ASCII format, and that conversion was done and placed it over here. So is this understood?
Yes.
So,
So basically every layer is adding its own header information and it is adding its own footer information. Now the header and footer is important to know because these 30 bits whatever you're sending, it is just a set of bits, right? 00 is something like a trail of bits. So like it will look, the in reality it will look like just bits like 00110, sorry, 1011100. Now where does it start and where does it end? That is the question. So that is why you have to know which part of the data, where does the applications layer start and where does it end, where does the presentation layer start and where does it end. So presentation layer is surrounded around the application layer and presentation layer is surrounded by the session layer. So every layer is surrounded by some other layer, but ultimately when you're sending the data, it is going like a trail of bits. On the other end, somebody has to know where is the start and where is the end, and what is the piece of information in each part of those bits that has to be interpreted. So um, so there are essentially 7 layers in the OSI, and we'll try to understand each layer a little bit more. So when we talk about physical layer, data link layer, network layer, if you notice, these are the bottom most layer. So these layers are got to do, mostly they deal with hardware problems. Your other layers like your transport, session, presentation and application layer, these are like your software layers. They deal with communication with your softwares, because ultimately the hardware data has to be converted into software data. So ultimately OSI is a mix of hardware layers plus software layers. So what is the bridge? So this three part, they represent your, mostly it will have your software data. The first three will mostly have your hardware data, and hardware data or hardware address is like MAC address, IP address. All this will come in hardware. So what is the bridge between your hardware and the software? It is your transport layer. So this is where your TCP protocol is used. So when we say protocol, what does it mean? Tell me. What do you understand by protocol? Protocol is a is like any language, right? So in any language you have words which mean something. So ultimately it is a way to communicate. In our English, sorry, in our verbal language, what all every we have so many languages. So every language is like a protocol, and every language has a particular set of words which mean certain things. The way it is constructed, that entire grammar and the syntax and the semantics forms your protocol, forms your language, and that is what protocol means. So every layer, in order to talk to the other layer, let's say if one physical layer on one device wants to talk to another physical layer on another side. So this is one language, physical language, you can say. One another language, data link language. Third language is network language. Fourth is your transport language. So there are 7 languages being used to communicate across, because let's say WhatsApp wants to send some data to another WhatsApp software on some other device. WhatsApp should have a language to talk to. So that is where this different protocols are used when different languages are used. You can think of that way. So in the application layer, what is the most famous language used on the web, or what is the most famous protocol used on the web?
So is it HTML?
Is HTTP.
Oh, HTTP.
Yeah. So this layer, if I want to, if the browser and the web server has to talk to each other, if they have to understand each other, they have to talk in HTTP language. Okay. So HTTP language means get, put, post, and the file name. Let's say my.html, something like that. So you need to talk in using some commands, and that what is the set of commands will is defined by the particular protocol, and this protocol is what? HTTP. So if you look at the protocols, every even if it is one device to another device, there has to be some way of talking to each other. No, that I have sent a signal, now you receive it, now you have received it, send me back an acknowledgement. There has to be some way of protocols. So what protocol are you going to use at what layer depends on what layer it is. And this layer, this layer basically is used by all applications. HTTP is used by all web applications. If you are uploading and downloading a file, then you would use an FTP protocol. If you are sending email, you would use a SMTP protocol. If any other protocol, so basically this has got to do with all application to application protocol. Okay. At this layer, one HTTP application is talking to another HTTP application. So like browser and your web server. In FTP, one is your client application which is uploading the file, and another server is accepting the file, and it is placing in the directory. So at FTP level, you will see directories and files. At HTTP level, you will see HTML pages and etc. So that is what in SMTP you will see email subject from to body. I mean, this will be the content of that SMTP, because how will the other person or the email application know who is sending to whom, what is the content body? So all that is a part of a language. Now that language is defined by SMTP. So do you understand now when I say SMTP, FTP, HTTP, ultimately the same bits are going, but what is the language I'm speaking, what these bits mean, that has to be interpreted by the protocol. Is this clear?
Yes, sir.
Okay. So in this diagram, I am representing a physical layer. So on one side there is a device A, and other side there is a device B. So what is in order to for the device A to this cable to operate, your electrical signal will go. So on one side, the electrical signal will be switch on or switch off. But the thing is, the other side also has to know. Now I have to look out for next signal. Now the next signal will come, whether it is on or and then interpreted as on or off. So voltage differences as to electrical signals, when you say switch on and switch off, it would mean, it can also mean voltage difference, which means if I send plus 5 volt, it means on, it is 1. If I say send minus 5 volt, it means 0. So continuously these signals are sent from one end to other end to send the data. If device B wants to send a signal to device A, then again the same pattern will be done. Device B will trigger a signal and device A has to accept it. If both have to talk to each other at the same time, then you have to use the medium has to support full duplex. So what is a full duplex?
So where it can send and receive at the same time.
Same time, which means the same line So you can send and receive at the same time. What is half duplex?
Only one action can be performed at a time.
Right. So now in device clock synchronization is very important, right? That now means now this clock has, if it is operating every 1 second, this clock also has to operate on 1 second. So there has to be a clock synchronization to both the clocks. If somebody is measuring the time taken for the runner to complete his race, the clocks cannot be unsynchronized. You know, the clocks have to be synchronized to come up with the same time, and based on the synchronization, we know now the next set of data will come in, and then interpret the data, and that's it. Once you once a signal is given, let's say one signal is sent over here, one signal is given to here, this device, right? What is the next step then? What do you do with this one signal? Like, I know this is a 1 now. What do I do next step? What is connected to the device? Remember the devices which I spoke about? What is there on every device? I spoke about devices, NIC, routers, switches.
Yes, sir.
So device is connected to what?
Device is connected to the web.
No, what
Internet,
hardware device?
internet networks.
Network
Internet network.
interface card, no?
Oh, NIC, yeah.
Like, is it very confusing what I'm saying, or I mean, it's still clear, right? It's okay if you forget, but you are now that I've told you network interface card, you understand, right? Network interface card.
Yes, sir.
Yes, sir.
Yeah. So this one has to be sent to the network interface. So this layer, at till then it is cable, one cable endpoint to another cable endpoint. It is a physical layer. But the network interface card then has a job of taking the signals, taking these ones and zeros, and passing it on to the next layer. So so let's see the next layer. So this is your next layer. So what you're seeing, this is a red line is your cable line, and cable line where it is connected to NIC. Your so it is like your Ethernet cable is connected to NIC. Now NIC, uh, uh, the main job is this cable on one end it is connected to a switch, right? Now how do you know this why this data is going on this line, but for whom the data is going for? So how do you know? It is through the MAC address. So MAC addresses are are special addresses attached to the device or to the NIC. So which MAC address of NIC, this right hand side NIC may be 2. The MAC address of the NIC on the left hand side may be 1. So MAC addresses, so data link layer is in play over here, where it is not about only at the physical layer, it is about your clock synchronization, your sending the bits 0 and 1s. But at this layer, MAC addresses are important information, where the data link layer tries to determine which MAC address I need to send the data to. The switches are this, when you connect this switch over here, this switch gets the MAC address equal to 2, and this switch gets the MAC address equal to 1, depending on which device you are connected to. So this switch knows like this port is mapped to MAC address 1. This right hand side switch knows that this is mapped to MAC address 2. Okay, so MAC addresses are used internally, you can say, like internal to the network. So this switches is like your internal switch. You have connected 4 devices. It has got nothing to do with even IP addresses. If you just tell me the MAC address at this level, I will come to know which computer you want to send the information to. And that is all that is required at the data link layer. So the data link layer, they don't send bits, they send frames. Frames is like one frame can be 512 bits. So 512 bits will be traveling on this line. So as I said, 512 bits will travel on this line, and this 512 is packed into a kind of a data set called frame. So this frame now contains how many bits? 512. So this is one frame. So there is a frame, there will be a point where frame will start and frame will end. At 0 it will start, at 512 it will end, then 513 it will start, then another 1024 it will end. So so data link layer operates, they don't deal with bits, they wait for 512 bytes to come in. They say let the cable send the 512 bits, let me construct the frame, and once I construct the frame, in data link header, what is the piece of information will be there, which is the most important piece of information in a data link header or footer? What is required for the data link layer to send the data to the other side? What piece of address is required?
MAC address.
Correct. So definitely you have to tell the from MAC address and to MAC address in the data link layer. That data link layer will make sure. So this piece of data link layer has got nothing to do with which application it is going to. It is got to do with which device it is going to, and devices are recognized by MAC addresses. And when one data link layer wants to send the data to another data link layer, it has to send in sets of 512 bits. In this, once this 512 bits is sent, it becomes like one frame, and frames is what it sends and receives. If the data link layer wants to send the data to the next layer, it is doing nothing but giving frames. This is my next frame, this is my second frame, this is my third frame. So next layer is about data link layer, which is the next layer. So one is physical layer, data link layer. What is the next layer? Remember anything? Have you all understood this much? Data
Yes, sir.
link layer. Okay. The next layer is actually your network layer. So you have to understand our in the data link layer diagram, this network can be inside your room with two devices connected to a switch. But our real networks, they are not confined to the devices inside a room. No, we also connect to devices outside a room, and that is where what is used in that place to connect to the network outside a room. What is used? What device connects networks? What do you see on the table, on the diagram?
IP address.
What is this word? Routing, right?
Routing table.
This
Okay.
device is what? Routers.
Routers.
Yeah. Routers lets you move out of your room and connect to somebody else on some other network. So network layer where it is operating now, as I told you, your physical layer is operating at the cable level. Your data link layer is operating at the NIC and switch level. But what is operating at the network level? Network level routers. What is the
Router.
for router MAC addresses does not matter. For router, what is matters is IP address, because it understands the list of IP address in terms of network of networks. This IP address means this network and this device. That IP address means that network and that device. MAC address only means this device and that device. It does not mean this network and that network. So do you understand the difference between MAC address and your you know your IP address. Your MAC address is like kitchen is number 1, bedroom is number 2, and hall is number 3. That is like your MAC address. It is internal, but it does not matter what is the house number at that particular time. My house number is, let's say, 606. It doesn't matter if you are doing an internal communication. Yeah, MAC address is good enough for internal communication. But if you want to now know which room you want to go into, which flat, then you require the flat number, and you may require the room, the actual kitchen number. So that is what is represented by your IP address. So IP address is used to determine not only the rooms inside your house, but all the computers inside or the devices in your network, but it is also used to identify the devices in outside your network. And that's why routers, they don't deal with MAC addresses. Routers deal with IP address. And how does the IP address looks like? 10.0.0.2. So each number is like 4 bits. So this is like 16 bit 8 bits each number. So 8 bits 8 bits means maximum the value that 8 bits can represent is 255. So the maximum value this can be 255.255.255. That is the IPv4 address. If it is IPv6 address, it is a bigger length. It is a 128 bit, 256 bit. It can be bigger addresses. So, but these addresses ultimately are used by routers to identify devices on the network. So that is what your network layer is all about. Okay. So your routers, what does it contain? Your routers basically has a routing table. Like if this source and target means if the data is coming from this source and it wants to go to this destination. So in order to go to this destination, what is your next target? What is the next stop? As I told you, if I want to go to Sikkim, what is your next stop from Mumbai Central? Maybe Borivali. So Borivali is not your destination exactly. So Sikkim is your destination. But what is my next target? Next target is my immediate next router that I want to go to. So this is what routing table helps you to tell. It is a way to tell the it is a way to help your router to decide what is your next stop. So you can create routing tables. If you can connect to a router. So when router they send data from one IP address to another IP address, that is so who is dealing with this layer? Network layer. So where is the network layer operating? It is mostly operating at the switch level and the router level. And what is the header will contain in the network layer? What is that piece of information which will be most important in the network layer?
IP address.
Very good. So at this level, I don't need to know what is a MAC address. What
MAC address.
is a IP address? Okay. So once I know the IP address, I know the device, no matter which network this device belongs to in the world. But also the network layer, when it packs the information, that whole set of data is called a packet. So the data that is packed at the data link layer, what is it called? The data link layer, when it packs the data, that one set of 512 bits, what it is called? It is called frame.
Okay, MAC address is considered
Yeah,
as
it
frame.
contains
Okay.
this 512 bits definitely contains a MAC address, but that entire set of bits is called one frame. Data
Frame.
layer, when it sends the data to network layer, it will give one frame. But that packet, this packet may contain one or more frames also. It is possible, no? So that I may have one or more frames. So network layer deals with packets. It doesn't deal with only it can contain one or more frames. Is this clear?
Yes, sir.
Yeah, it is like taking somebody is giving you all the classmates they are giving a gift to one person, let's say. So every person packs their gift in one box. So that box can be framed. So every then you take all those small gifts and then you put a bigger box around it and you pack it and then you label it. Then that can become your packet. And that is what you parcel. Is it understood the difference between frame and packets? Packets will definitely contain the frame, but it will be wrapped in the network layer protocol format. Is this clear,
Yes, sir.
Anuj?
Yes, sir.
Is it very difficult to understand what I'm saying? Is it getting very complicated?
No, sir.
No, sir.
Okay, so we have actually spoken about three layers. I thought I'll speak about all layers, but this itself takes time. So I want to like give a logical end to this. Now, so far you have been dealing with routers, switches, NIC, cable. Is this hardware or is this software?
Hardware.
Hardware, sir.
Hardware. So right, so these layers, that's why we say these are called hardware layers. Only hardwares are talking to each other. So your physical layer, data link layer, and network layer. So out of the 7 layers, we have the hardware layers. And any other question you'll have so far?
No, sir.
No, sir.